Have you ever gazed up at the stars and wondered if we are truly alone in the vast, infinite expanse of the universe? The age-old question of whether life exists beyond Earth has captivated the imagination of humankind for centuries. With each passing decade, science has brought us closer to answering this profound mystery, and yet, the question still looms large in our minds. But what if we are finally on the verge of an answer? What if the discovery we've been waiting for, something that could forever change our understanding of life in the cosmos, has already been made? Welcome to the latest chapter in the search for extraterrestrial life. In September 2023, an exciting and unexpected breakthrough happened when the James Webb Space Telescope, JWST, spotted something remarkable on an exoplanet called K2-18b, located 120 light-years away in the constellation Leo. The telescope detected a compound called dimethyl sulfide, DMS, a sulfur compound that on Earth is produced solely by life forms. Could this be the moment we've all been waiting for? Could this discovery mark the end of the centuries-long quest to answer the question of whether we are alone in the universe? Before jumping to conclusions, it's important to note that the scientific community is still processing the implications of this find. While some scientists are celebrating what appears to be a clear sign of life beyond Earth, others are calling for more caution. After all, the capabilities of the most powerful space telescope ever built are still limited, and there are many factors at play that make the detection of extraterrestrial life far more complex than simply identifying a compound that is associated with life on our planet. But the fact remains, something incredibly exciting has been discovered. So, let's take a deep dive into this revelation and explore what it means for the future of space exploration, and more importantly, what it might tell us about life beyond our world. DMS is a compound that many people have probably never heard of, but it plays a crucial role in the study of extraterrestrial life. On Earth, DMS is primarily produced by microscopic organisms like phytoplankton in the ocean. These tiny creatures emit the compound, which is responsible for the characteristic smell of the sea, a scent many of us associate with the beach. But DMS is much more than just a smell. It is a significant biomarker for life. This sulfur compound is typically produced by biological processes, and until recently, we had only ever detected it in the context of Earth's ecosystems. The fact that the James Webb Space Telescope has detected it on K2-18b, a planet light-years away, raises intriguing possibilities about the potential for life elsewhere in the universe. The presence of DMS on K2-18b isn't just an isolated finding. It's part of a larger trend in recent space exploration. The search for biosignatures, which are signs of life, has been a major focus of astronomers and astrobiologists for decades. And while many planets have been identified as potentially habitable based on their location in the so-called habitable zone of their stars, the discovery of specific compounds like DMS could provide more concrete evidence of the possibility of life. So when the news broke that DMS had been detected on K2-18b, the scientific community was understandably thrilled. This planet, which has been referred to as a water world, or a planet covered entirely in water, could potentially offer the conditions necessary for life to thrive. The discovery of DMS, however, doesn't automatically mean we've found extraterrestrial life. There are still many questions that need to be answered. For example, scientists are still trying to confirm whether the DMS detected by JWST is truly of biological origin or if it could have been produced by some other, non-living process. On Earth, the production of DMS is heavily tied to marine life, specifically phytoplankton, which are at the bottom of the food chain in the ocean. But could DMS form through other chemical processes in space? That's one of the main reasons scientists are cautious about jumping to conclusions. The existence of DMS alone isn't enough to definitively prove the presence of life on K2-18b, it simply raises the possibility. K2-18b, the planet in question, is a fascinating world in its own right. Located in the constellation Leo, it orbits a red dwarf star at a distance of just 0.14 astronomical units, AU, which is about 14% of the distance between Earth and the Sun. Despite being much cooler than our Sun, the planet receives a similar amount of radiation from its star, which places it in the habitable zone, the region around a star where conditions are just right for liquid water to exist. This is a critical factor in the search for life because water, as we know, is essential for life as we understand it. The discovery of water worlds like K2-18b has sparked great interest in the scientific community, as these planets might possess the right conditions for life to take hold. In 2015, the Kepler Space Telescope first identified K2-18b, and since then, astronomers have been studying it closely. Despite being much smaller than Earth, this exoplanet has a number of characteristics that make it a promising candidate for habitability. It's large enough to retain an atmosphere, and with the right amount of radiation from its star, the surface could support liquid water. However, the challenge of determining whether life exists there, or ever existed, remains daunting. One of the major hurdles is the atmosphere itself. K2-18b's atmosphere is made up of a mix of gases, including methane, carbon dioxide, and water vapor. These compounds, while potentially supportive of life, also complicate the detection of other biosignatures like DMS. Methane, in particular, presents a problem. The presence of methane in the atmosphere of K2-18b is significant because methane is often produced by biological processes on Earth. However, it can also be generated by non-biological processes, such as volcanic activity or chemical reactions between water and rock. The challenge, therefore, is distinguishing between methane that might be produced by living organisms and methane that could be the result of geological processes. This is where the detection of DMS becomes crucial. DMS, as a compound associated with life, could potentially offer a more definitive clue that something biological is happening on the planet. However, the detection of DMS on K2-18b is far from straightforward. The molecule appears at a specific frequency, 3.4 micrometers, on the spectrum detected by the James Webb Space Telescope. Unfortunately, this frequency overlaps with the signature of methane, making it difficult to isolate and confirm the presence of DMS. This issue points to one of the inherent limitations of current space telescopes. While the James Webb Space Telescope is the most advanced instrument of its kind, it still has constraints when it comes to separating different signals in a crowded spectral range. This is why the scientific team working on this discovery is urging patience and caution. The initial signals of DMS were detected, but much more data analysis is required before any definitive conclusions can be drawn. In fact, the challenge of detecting and confirming DMS on K2-18b is so complex that scientists are now focusing their efforts on gathering more data using different parts of the James Webb Space Telescope. One of the key methods being explored is the use of the telescope's mid-infrared spectrometer, which operates in a different range of the electromagnetic spectrum. This spectrometer is capable of detecting molecular signatures in the mid-infrared range, which includes the frequencies where DMS is likely to be found. Researchers are hoping that by observing the planet in this range, they can isolate the DMS signal from the background noise created by methane and other compounds in the atmosphere. In addition to the observational challenges, there's another issue at play: the rapid decomposition of DMS in the atmosphere. On Earth, DMS breaks down quickly when exposed to sunlight, a process known as photochemical degradation. For the DMS on K2-18b to be detectable, the planet's atmosphere would need to have a high concentration of DMS, much higher than we see on Earth. According to some models, the level of DMS on K2-18b would need to be at least 20 times greater than what we detect in Earth's atmosphere to be noticeable to the instruments we have available. This is because the compound breaks down rapidly in the presence of ultraviolet light from the star. However, some researchers suggest that a protective effect could prevent the rapid degradation of DMS in the lower atmosphere, creating a stable environment where the compound could accumulate and become detectable. Even though we are still in the early stages of understanding the full implications of this discovery, the potential for a breakthrough is enormous. If DMS is confirmed as a biosignature on K2-18b, it would represent a monumental achievement in the search for extraterrestrial life. It would not only provide evidence that life could exist on other planets, but it could also change the trajectory of future space exploration. The discovery of a clear biosignature like DMS would pave the way for more targeted missions to exoplanets in the habitable zone, allowing us to explore worlds beyond our solar system with a renewed sense of purpose. At the moment, the scientific community is abuzz with anticipation. Researchers around the world are eagerly awaiting the results of ongoing data analysis, hoping that the elusive presence of DMS can be confirmed. While we may not yet have definitive proof of life on K2-18b, the fact that we are even having this conversation is a monumental step forward in the search for life beyond Earth. It's a reminder that the universe is vast and full of mysteries, and we are just beginning to scratch the surface of what might be out there. In the coming months, as the data is processed and analyzed further, we may get closer to answering one of humanity's most profound questions. Are we alone? Could life truly exist on other worlds? The discovery of DMS on K2-18b might not be the final answer, but it certainly opens the door to new possibilities, new discoveries, in a future where the search for life beyond our planet becomes more than just science fiction. So, stay tuned, this is just the beginning of an incredible journey that may one day lead to a new chapter in the history of humanity's quest for knowledge.